Math 92, in the beginning of this chapter, we talk about review of some pre-algebra. I just circle those definitions that you really need to understand it. Like, what's the difference between natural numbers and the whole numbers? The main difference is whole numbers has 0 in it, and these are all positive numbers, okay? So natural numbers are all positive numbers, and whole numbers has 0 in it. And they have an example here, like when we count the number of wheels, such as bike or the cars, it's clear that the vehicle have 1, 2, 3, 4 or more wheels. Counting the number of wheels, example of natural numbers. But if you want to count up the number of people in a room, then you could also use 0. So these are just some of the definition you need to remember if you were asked what's the difference between natural number and whole numbers. That's what it is. We also have integers. Integers, they have all the numbers, positive, negative, and 0. It's like a number line. You know, the number lines. So it has 0, positive, and negative. So that's what integers is. Number lines. Number lines is a straight line, is divided into equal pieces. There is the initial point, which is 0. And as you go to the right, number increase. You go to the left, number decrease. It goes all the way to positive infinity and negative infinity, like a straight edge. And then they might have a different scale. Like in this example, the scale is 10. The tick marks on the lines are 10 units apart. See, go from 0 to 10, 10 to 20, 20. So what's the scale? 10. On this one, it goes from 0 to 0.5, 0.5 to 1. So what's the difference? 0.5. So the scale is 0.5. Like on this one, the initial point is 0. It goes from 0 to 5, 5 to 10. So what's the scale? 5. Tick marks are 5 units apart. So that's what the number line is. Then on section R1, you could also find this on your textbook. So let me see what page is it. Doesn't have a page. It's hidden here, but this is, I copied this from your textbook. Now, let me clear this a little bit so you can see it better. You know, when we are using some terms and we want to know what's the translation that to the algebra is this. When we say A is less than B, this is a symbol we use. Like 5 is less than 10, or 5 is smaller than 10. A is greater than B. In algebra, this is an inequality sign. This is the symbol we use. Like on the number line, if you pay attention, like this 2 and negative 2. See, 2 is here and negative 2 is there. So number on the left is smaller than number on the right. Or number on the right is greater than number on the left. So 2 is greater than negative 2. A is less than or equal. When you say less than or equal, then along with inequality sign, you also have equal. So this is a symbol we use. Okay. A is greater than or equal to B, same thing, you have that. If they say B is between A and C, it's like 5. 5, see 5? 5 is a number between 7 and 3. You see that? 5 is between 7 and 3. That's how we show in algebra. That's the symbol we use. 5 is less than 7 and greater than 3. So we do something like that. B is between A and C, including A and C. In that case, when you say including, you also, along the inequality sign, you also have equal sign. A is equal to B. This is a symbol. A is not equal. When it's not equal, this is a symbol we use. These two are not equal. A is approximately equal to B. This is a symbol for that. As you go through this video, if you want to make a note, you could always pause it, and that'll give you more time to copy or understand it better. Here they ask us to the following number line to determine which number is larger. Like they have -2 and -5. -2 is larger than -5. Why? Because look, -2 is here, -5 is there. Number on the right is greater than number on the left. So for the negative numbers, -2 is greater than -5. See, as you go to the left, number decrease. You go to the right, number increase. So any numbers like, look, 3 and -5, obviously 3 is greater than -5. But when you compare to negative number, again, number on the right is greater than number on the left. Like -6 and -1. See, -1 is here, -6 is there. So -6 is less than -1. The next definition is the absolute value. Absolute value is the distance. Okay? So what is the distance between -6 and 0? See, 0 is here, -6 is there. How many units is from here to here? 6. What is the distance between 6 and 0? 6 and 0. How many units? 6. Can a distance be positive? Yes. Can a distance be negative? No. You can say I live -10 miles from here. So absolute value always has to be positive. Why? Because it's distance. Absolute value of a number is a distance between that number and 0. The symbol they've used for absolute value is 2 bars, like that. So what is absolute value of -5? When you want to bring a number out of the absolute value, that number always has to be positive. Why? Because it's a distance, like 5 miles or 5 feet. So any negative number leaving the absolute value has to be positive. But if the number is already positive, it remains positive. The outcome here always has to be positive. What is absolute value of -10? Is 10. Let's say 10 miles, 10 feet. So the number comes out of the absolute value always has to be positive. Why is the distance? Like here, let's say on the number line, -10 is here, and this is 0, right? Absolute value of -10 is, what is this distance? Then you say is 10. or 10 feet or 10 inches, just depend. If it's in inches, it's 10 inches. Okay, so that's what the absolute value is. The next definition is opposite of a number. Opposite of any number has the same absolute value but different sign. So what is opposite of -7? 7. So the difference is a plus or minus. So if your number is already plus, then opposite is negative. If the number is negative, the opposite is positive. Look here, the symbol is this. What is opposite of -7? -7 means opposite of -7. So either say this, what is opposite of -7? Question is, what is opposite of -7? The answer is 7. Or instead of writing like this, what is opposite of -7? We just say, this means what opposite. What is opposite of -7? Or another way of understanding this is this. You know, when you have negative and like -7, if you don't see any number after the negative, you put a 1 here. Parentheses is sign of multiplications. So this means -1 times a -7. When you multiply two negative numbers, the outcome is always positive. You could even use your calculator for that. Okay, so let's say you have this 2 times -5. Parentheses again is sign of multiplication. What is, when you don't see any symbol here for the sign, is always positive. So if you don't see anything here, it's positive. You put a sign if it's negative, but if it's positive, you don't have to put anything. But here, +2 times -5, +2 times -5 is -10. Okay, so when you say what is opposite of 8, what is the symbol for the 8 here? I don't see any symbol here or any sign here. So that means it's positive. Okay. What is opposite of 8? Opposite of 8 is -8. You could either say it this way, or you just say minus times -1. If you don't see any number, put 1. What is -1 times +8? -8. Okay, so that's what opposite is. So what is opposite of 6? -6. What is opposite of -7? 7. Next subject is extremely important, is order of operations. Order of operations here. You always do multiplication or division and then addition and subtraction. For example, let's say we want to do this. 2 dot means multiplications. So it is like this, 2 times 10 divided by 5. Now, does that mean that I have to take 2 multiplied by 10 first, which is 20, and then divided by 5? Or, so it's like this. Do I do this first? 2, let me write a piece of paper. 2 multiplied by 10 divided by 5. There are 2 ways to look at this. One is, okay, 2 multiplied by 10, you do this first. So it will be 20 divided by 5 is 4, okay? Or you might say, all right, this is, maybe I should do this first, 10 divided by 5, which is 2, and then it's 4. Which one of this? In multiplications, and divisions, when you have both present, when you have division and multiplication both present, you always go from left to right. So you just say 2 times 10 is 20, divided by 5 is 4. But when you have addition and multiplication, you should always do multiplication first. I think this is a better example here, look. See here, what we have is this. 4 times 3 plus 8. So problem is this, right here. 4 multiplied by 3 plus 8. Okay? Shall I say 3 plus 8 first? Shall I do this and just say 4 times 11, which is 44? Or shall I say 4 times 3 is 12 plus 8 is 20? See, in this case, you come up with 2 different answers. Which one is correct? The law is this. You always do multiplication first and then addition. Multiplication is before addition, okay? So in that case, I gotta do multiplication first and then addition. This is not correct. Why? Because you are doing addition first and then multiplication. So that's what the law is. All right, so here. So you do multiplications and then you do addition or subtractions, okay? There are some good examples here. Like here I have, when I look at this expression here, this one, see, we do, these two are, one is multiplication, one is division. So you do these two first. And then another thing is, then they ask you how many terms. Terms are always separated by plus or minus, okay? So here, this expression, 6 negative 4 times 5 plus 10 divided by 2, we want to calculate the number of expressions. This one has 3 terms. Why there are 3 terms? Because you have 1 is positive, negative. Positive or negative would separate the terms. So 1 term, 2 terms, and then the third terms. Like this one, anywhere you see a plus or minus, that separate the terms. Plus or minus would separate the terms. So how many terms you have here? 1, 2, 3, and 4. So you have, there are 4 terms here. Do you see any plus or minus here? No, so it's just 1 term. Because I don't see any plus or minus. It's just 1 term by itself. Okay? So that's definition of the terms. Terms are always separated by plus or minus. So there are more examples in this page here. Plus and negative. So you have 1, 2, 3 terms. The reason we circle this, because you do the multiplication first. Multiplication is always before addition or subtraction. So you do 6 times 3 first. And then you do addition and subtractions, okay? Now you could take 9 and 2 and add first and then subtract 18, or you could just say 9 minus 18 is negative 9 plus 2. Why is 1 term? I don't see any plus or minus. The whole thing is just 1 term. See? Where I see plus or minus, I separate the terms. 1, 2, 3, and this is 4 terms. Negative, positive, negative. So there are 1, 2, 3, and 4. R2, we have, they call it prime number. Prime number are the numbers that you cannot break it. 2, 3, 5, 7, 11. Like, is 8 a prime? No. Why not? Because 8, you could break it into 2 times 4. Is 12 a prime? No. 12 is 3 times 4. Is 11 a prime? Yes, you cannot break 11. It's just 1 times 11. Is 13 a prime? Yes, you cannot break 13. Is 18 a prime? Yes, because 18, it could be 3 times 6, it could be 2 times 9. So if there is a number that you cannot break it into some factor, it is a prime numbers like this. 2, 3, 5, 7, 11, 13, 17, 19, and go on. When you have a number, you could always break it into some factors, like 48. 48 is 12 times 4, and then 12 is 4 times 3 and 4 times. See, you break it into some primes at the end. So 48 is 2 times 2 times 3 times 2 times 2, or this is 48. This they call it prime factorizations, means you are taking a number and you break it, you take a number and you break it into some primes. They call it prime factorizations. Then we have GCF, they call it greatest common factor. Is there a number common between 8 and 20? So first you break the 8. 8 is what? 8 is 2 times 2 times 2. 20 is 2 times 2 times 5. So they both have 4 in common. You see that? That they call it greatest common factor, GCF. So what you do is you prime each first, means you break 8, you break 20 into some primes, and then you see what numbers do they have in common. Like this one has 4, this one has 4. They both have 4. Or you could just say this way, look, 8 is 4 times 2, and 20 also is 4 times 5. They both have 4 in common. So that is greatest common factor. They also did for 12 and 18, you know. 12 is 4 times 3. 18 is 2 times 9. You break it. See? They both have 6. Because 12 is 2 times 6. And 18 is 3 times 6. So what do they have in common? 6. That is the greatest common factor. Talk about the fractions. What is the fractions? 1 over 2. Number on the top, they call it numerator. Number at the bottom, they call it denominator. And this is a fraction bar. 2 over 4. If you take a circle and divide it into 4 equal pieces, if you take 2 pieces out, so 2 out of 4 means this. 1 over 2. Take a circle, divide it into 2 equal pieces, take 1 out of 2. Then we have reduce a fraction to a lowest term. When we ask you to reduce a fraction into the lowest term, look at this, 9 over 18. Okay, 9 over 18 is 9 . 9 divided by 18. 9 times 1, 18 is 9 times 2. 9 and 9 cancel, so 1 over 2. So when we ask you to write a fraction in the lowest term is this you cannot simplify it anymore. Like 16 over 36. 16 is like what? 4 times 4, and 36 is like 4 times 9, right? 4 and 4 cancel. What is the outcome? 4 over 9. That means we are reducing a fractions to we cannot simplify this anymore, correct? So when you say a reduced fraction to a lowest term, that's what it means. $25 over 70. 25 is what? 5 times 5. And 70, you could take your calculator and divide 70 by 5. 70 divided by 5 is 14. So it's 5 times 14. 5 and 5 cancel. So the outcome is 5 over 14, okay? That's what we call it, reductions to the lowest term. You cannot simplify. 5 and 14, they don't have anything in common anymore. Now here we have the number line like this one. And what is the scale of metric side of the ruler here? So you see this is the inch and this is a centimeter. Okay, that's the scale. And let's say we want to draw 1 and 5/16 inches. So when it's inches, you go to the top one. 5 over 16. Okay, and what you could do, you could just take the 5 and divide by 16. What is 5 divided by 16? 0.315. So basically we are talking about 1.3125, just say 1.3. Okay, here, this is 1 inch, 2 inch, 1.5. So 1.3, you just count the numbers, okay? This is 1.5, 1.3 is 1, 2, 3, somewhere here. You could change it to the decimal. You either do that or you could, this they call it mixed number. 1, 5, 16, they call it mixed number. What you could do is this, you just say, I'll take 16 and multiply by 1, and then add to 5. So 16 times 1 plus 5 is 21. You use that for the numerator. So that would be 21 over 16. So what you do is you just take a mixed number and change that to improper fraction, 21 over 16. Or the other one, this one, 11, 7, 10. 11, 7, 10. Take the 10 and multiply by 11, 10, multiply by 11, and then add 7 to it. So that would be 110 plus 7 is 117. So that would be 117 over 10. Okay, that's conversion of mixed number to improper fractions. And then you could, you could also divide it. If you want to find it on the ruler, you could just divide this. So this would what, 11.7, they said 11.7 centimeters. So you just go here and find the centimeters, it's with 11.7. But these are, these are good examples here. What is a scale of this number line? A scale of this number line is 0.5 or half. You can see 0.5, 1, 1.5, 2, and so on. Graph half. What is that? It's 0.5, right? 1 over 2 is 0.5. So that's what you graph it. Minus 3/2. When you use your calculator, what is 3 divided by 2? 1.5. But you have minus 1.5. Minus 1.5 is here. So that's how you graph a point. Then we come to addition and subtractions. When you're adding two fractions with the same denominator, you could just have one denominator and add the numerator. The second one, I have a mixed number. So I change this to improper fractions. 8 times 2 is 16, plus 3 is 19. 19 over 8 minus 7 over 8. When you're subtracting two fractions with the same denominator, you just write one denominator and you subtract the numerator. So the outcome is 3/2, or if you want to change it to the mixed number, you just do it like that. Because 3/2 is what? 3/2 means 1.5 or 1 plus 0.5 or 1 plus half or 1 and 1/2. If they ask you to write it as a mixed number, that's how you do it. So this is in case you have the same denominator when you're adding or subtracting two fractions. This is an example that two fractions do not have the same denominator. So 5 over 3 plus 5 over 6. Our goal is to change these two to the same denominator. So 5 over 3, and this is 6. So to change 3 to 6, I need to multiply numerator and denominator by 2. 10 over 6, we write 10 over 6 instead of 5 over 3. Now they both have the same denominator. Okay, so look, if I have 5 over 3, if I take this and multiply by 2 over 2, which is 1, you change it to 10 over 6. The fraction appearance changed, but the value still is the same. It's like half. Look at half. You know, 0.1, half is 0.5, right? Let's say we take this and multiply by 6 over 6, which is 1. We multiply by a fraction, the numerator and denominator are the same. So in that case, you have 6 over 12. Is 6 over 12 and half are the same fraction? Yes, because 6 over 12, when you divide, also give you 0.5. So you're allowed to take a fraction's numerator and denominator and multiply by the same number. That doesn't change anything. It just changes the appearance, but it doesn't change the value. So that's what we do here. Because we have 6 here and we have 3 here, we take the numerator and denominator and multiply by 2. So instead of 5 over 3, I have 10 over 6. Then I can add. Like this one, 12 and 8. 12 and 8. 12 is 3 times 2 times 2. 8 is 2 times 2 times 2. So you see they both have 4, but this one has 2. This one doesn't have 2. There is a 3 here, but not the 3 here. So you multiply the second one by 3 and the first one by 2. See, they both come up with the same denominator. Another term, they call it reciprocal. Reciprocal is if A is a non-zero, then 1 over A is the reciprocal of A. What is reciprocal of -7? It has to be a fraction, but if it's not a fraction, instead of -7, you just write -7 over 1. -7 over 1 is the same as -7. But when you find the reciprocal, it means you just flip this fraction. So that would be -1 over 7. What is reciprocal of 1 over 9? All you need to do is just flip this fraction. So it would be 9 over 1. Minus 2 over 3. Just pay attention to the number. 2 over 3, when you flipped it, is 3 over 2. That's what reciprocal means. What is reciprocal of 5 over 7? 7 over 5. What is reciprocal of 10 over 11? 11 over 10. What is reciprocal of 3? If you don't see any fraction, give a denominator of 1, because 3 over 1 is the same as 3, right? No. What is reciprocal of 3 over 1? 1 over 3. Negative doesn't make any change to it. Like, what is reciprocal of -5 over 7? 5 over 7 is 7 over 5, and you save the negative. That's what reciprocal means. Okay, so what I did was then this is end of R1 and R2. And then what I do is I go over R3 and R4, and then I give you a copy of the homework assignment that has the solution for you, and then you could go over that. I put everything on Canvas.